Welcome to Study Loop.
In this problem, you have two lenses, one convex, one concave, 50 centimeters apart. The convex has a focal length of 25 centimeters and the concave has a focal length of negative 40 centimeters. And we're asked to calculate where the image is being produced. This object is 2 centimeters tall, and the object is initially placed 30 centimeters in front of the first lens. So to do this, we can use the thin lens equation, which is 1 over dO plus 1 over dI equals 1 over F, and we can solve for 1 over dI. Now we want to get dI by itself, so we're going to go ahead and inverse, and we're going to inverse the entire thing. And this gets us a distance of the image 1 for the first lens of 150 centimeters. That means that it is somewhere over here. This is going to be labeled as 150 centimeters. And so if I take away the distance that is between these two, we're going to solve for a new distance of the object. So distance of the object 2 as 100 centimeters, and this is going to be a negative value because it is now on the right side of the lens. And then we're going to repeat the same process. So dI equals 1 over F, which is now negative 40, minus 1 over, and this gives us negative 100. And we get a new distance of the image as negative 66.66666, round to 7 centimeters. So that means that my image is being created to the left of the second lens. And we can use that to determine our magnification. Now our magnification is going to be dI1 times dI2 all over dO1 times dO2. So we get negative 66.7, if we round up, times 150, divided by 100, negative 100, times 30, gets us a magnification of about 3.33. So like we said, this is going to, the fact that this is a positive value, it means that my image will be upright. So since the final image will be formed on the left of the convex lens, that is the same side as the original light bulb, which means that this final image will be virtual. So this is a virtual image. Again, we got a distance of negative 66.7, which tells us, starting from our second lens, our concave lens, that we are about 67 centimeters in this direction. So my image will be located out here because that is beyond the 50 centimeters that separates the two lenses. So because the final image is to the left of my convex, my concave lens, this is, again, a virtual image.